Alright, so let's dive into 10 truly startling findings that scientists have uncovered from examining ancient DNA. All living things, including humans, have DNA. It transfers our characteristics to the following generation by carrying our genetic information. Additionally, it enables us to trace our ancestry back to our earliest ancestors. It also functions in the opposite manner. We can learn more precise details about our ancestry by comparing the DNA of prehistoric humans and prehumans with our own. These are only a few of the numerous insights that science has gained by examining ancient DNA. Number 10. Humans are descended from a single man and woman. All people are descended from Adam and Eve, the first humans to live on Earth, according to the Bible. This notion is partially supported by science, yet there are some intriguing distinctions. First of all, Adam and Eve in scientific terms were not the original people. Secondly, we are not their direct descendants. Rather, all women are descended from women, and all men are descended from men. Scientists refer to the lady as mitochondrial Eve, and the guy as Y chromosome Adam. Between 125,000 and 156,000 years ago, Y chromosome Adam resided in Africa. Between 99,000 and 148,000 years ago, mitochondrial Eve resided in East Africa. Although they might have been living at the same time, Y chromosome Adam and mitochondrial Eve are unlikely to have ever met, unlike the biblical Adam and Eve. After sequencing the Y chromosomes of 69 males from 7 distinct ethnic groups, scientists came to the conclusion that Y chromosome Adam was the ancestor of all men. They examined the mitochondrial DNA of 24 additional women and 69 men from mitochondrial Eve. Y chromosome Adam's age is up for question, though, since some research suggests that he may have lived between 180,000 and 200,000 years ago, or even between 237,000 and 581,000 years ago. Number 9. Different species of early humans interbred. A piece of bone from Denisova Cave in Siberia was discovered by archaeologists in 2012. The bone came from the shin or thigh of a prehistoric person known as Denisova 11. According to subsequent DNA testing, Denisova 11 was a female, lived approximately 50,000 years ago, and was older than 13 when she passed away. She was also a cross between the Neanderthal and Denisovan, two early human species. Denisova 11's mother was Neanderthal, while her father was Denisovan. It's interesting to note that Denisova 11's father was descended from a combination of Neanderthals and Denisovans, but his hybrid ancestor lived between 300 and 600 generations before him, in contrast to his daughter, who was a direct descendant. Neanderthals and Denisovans split apart 390,000 years ago, according to scientists. But until this finding, people were unaware that they interbred. Additionally, DNA testing revealed that the Neanderthal mother of Denisova 11 was more closely connected to Western European Neanderthals than to a Neanderthal who had previously resided in Denisova Cave. So, Tibetans are descendants of the Denisovans. When it comes to interbreeding, DNA testing shows that Tibetans are actually descended from Denisovans. But, just to be clear, Tibetans are still Homo sapiens, not Denisovans themselves. What happened was that one of their Homo sapien ancestors, at some point, mated with a Denisovan. When scientists compared the genomes of 40 Tibetans with those taken from Denisova 11, they found something pretty interesting. They noticed similarities between the Tibetan EPAS1 gene and the EPAS1 gene from Denisova 11. Now, every human has EPAS1. It's the gene responsible for controlling how our bodies react to low oxygen levels. When there's not much oxygen around, our bodies automatically make extra hemoglobin to help carry oxygen to our tissues. This helps us survive, but it does come with a higher risk of heart problems. But here's the twist. The EPAS1 gene is mutated in Tibetans, so when they don't have enough oxygen, their bodies don't make more hemoglobin, and that's actually what helps them survive at high altitudes, where oxygen levels are really low. Researchers think that somewhere between 30,000 and 40,000 years ago, one of the ancestors of Tibetans mated with a Denisovan, and that's how they got this gene. The altered EPAS1 gene might have helped Denisovans adapt to high elevations, just like Tibetans do today, but scientists haven't actually confirmed that yet. The first Brits were black. Back in 1903, scientists discovered the 10,000-year-old remains of a British man in a cave at Cheddar Gorge, Somerset, England. This individual, called the Cheddar Man, according to a 2018 DNA study, had either dark brown or black skin, curly black hair, and blue eyes. He is actually the oldest intact human skeleton ever found in Britain, which tells us that the first Britons were in fact black. And interestingly, in the 1990s, an Oxford University professor named Brian Sykes tested 20 residents of Cheddar Village and compared their DNA to Cheddar Man's. He found that 2 individuals were actually descended from Cheddar Man. King Richard III of England was a hunchback. In 2012, archaeologists from the University of Leicester started digging up a parking lot in Leicester. It turned out that the parking lot was the former site of Greyfriars Church, which is where King Richard III was said to have been buried. When they found the king's remains there, Richard III became pretty famous for being the monarch discovered under a parking lot. Scientists compared the skeleton's DNA to that of a living relative, and that's how they confirmed the skeleton really did belong to the king. They also matched the fatal head injuries on the skeleton to what was known about his death at the Battle of Bosworth. But that's not all they found. He had a bent spine, which finally confirmed what historians had been debating for years. The king really was a hunchback. One of the most well-known pharaohs to have ruled Egypt is King Tutankhamun. He began ruling at the age of 10 and passed away at the age of 19 in 1324 BC. In 1922, archaeologists dug up his tomb. They were shocked to discover it undamaged, complete with gold and other valuable stones. King Tut did not enjoy his brief life, according to a physical examination of his remains. He had to use a cane to get around because his left leg was malformed. In actuality, his tomb contained 130 canes. Additional DNA testing revealed that inbreeding was the cause of his malformed leg. In addition, he had a case of malaria, which would have prevented the healing of the malformed limb. According to DNA testing, King Tut's father was Akhenaten, the son of King Tut's grandfather, Amenhotep III. Additionally, DNA testing revealed that King Tut's mother was Amenhotep III's daughter. This would make King Tut's mother and father siblings. Although this has been contested because she was unrelated to Akhenaten, some historians maintain that his mother was Queen Nefertiti. The Clovis people were long thought to be America's initial settlers. They moved to South America about 11,000 years ago, arrived in North America around 13,000 years ago, and then vanished about 9,000 years ago. But DNA testing done in 2018 on prehistoric individuals actually tells a different story. According to DNA from ancient humans discovered in North America, the Clovis people lived there about 12,800 years ago. But things look a bit different in South America. DNA testing on the remains of 49 ancient South Americans shows that the Clovis people first arrived in South America about 11,000 years ago. Interestingly, archaeologists already have evidence that an unnamed culture was living in Monte Verde, Chile, as far back as 14,500 years ago. Since the DNA of this tribe is different from that of the Clovis people, a 12,800-year-old pair of human remains found in South America is believed to have belonged to them. The earliest proof that the Clovis people ever landed in South America comes from the DNA of an 11,000-year-old human. Scientists still aren't sure about the relationship between this mysterious culture and the Clovis people. However, since modern South Americans do not share DNA with the Clovis people, scientists are confident that this unnamed tribe did exist. Columbus did not introduce tuberculosis to the Americas. A lot of people think that in the late 15th century, Christopher Columbus brought TB and other terrible diseases to the Americas, and that 90% of Native Americans died because of these illnesses. But DNA testing actually tells a different story. Long before Columbus arrived, seals brought TB to the Americas. Scientists figured this out after examining 3 sets of human remains from Peru. It turns out that these people died about 1,000 years ago, which is 500 years before Columbus ever showed up. DNA testing showed that their TB strain was most similar to that found in diseased seals and sea lions. At the time these Peruvians died, there were devastating tuberculosis epidemics happening throughout Europe, Asia, and Africa. Scientists believe that during one of these epidemics in Africa, seals and sea lions accidentally carried the infection with them as they traveled to the Americas. When the indigenous Peruvians hunted seals and sea lions for food, they came into contact with this mutant strain of tuberculosis. Still, this doesn't mean Columbus and his crew were totally blameless. For all we know, they may have brought the deadlier European form of tuberculosis to the Americas. And today, the TB found in America actually has European roots. Descendants of the Vikings are actually at higher risk of getting emphysema, which is a pretty serious lung condition. This was found in a 2016 study by specialists from the Liverpool School of Tropical Medicine. Emphysema usually affects smokers the most. But when scientists examined a latrine from the Viking Age in Denmark, they discovered that the Vikings were so plagued by worms that their alpha-1 antitrypsin, or A1AT, inhibitor gene changed to block the worm's enzymes. Normally, the human body creates inhibitors like A1AT to keep strong enzymes from breaking down our organs. But for the Vikings and their descendants, the A1AT inhibitors' increased ability to deal with worm enzymes also made it less able to protect their bodies from their own enzymes. Now that we have medicine to treat worms, this mutant A1AT inhibitor isn't really needed anymore. But DNA testing shows that the mutant inhibitor is still around in Viking descendants. As a result, these descendants can end up with lung problems because their bodies just can't handle their own enzymes properly. Malaria has long been suspected of playing a role in the fall of ancient Rome, but now we have evidence that it really did afflict the empire and contribute to its downfall. In 2011, researchers discovered this after examining the remains of 47 infants and young children unearthed at an old Roman home in Lugnano, Italy. The oldest of these so-called Lugnano children was only 3 years old. All of them died and were buried at about the same time, and over half of them passed away before they were even born. These children fell victim to one of the malaria outbreaks that devastated ancient Rome and kept farmers from returning to their fields. The army, however, suffered the most, since it couldn't gather enough troops to defend against foreign invaders.